is a normal distribution? Remember back in September when we discussed bell curves? Our bell curve is our normal distribution, and that's what we're talking about in Chapter 7. And I'm at about 10 seconds behind on the video, so I'm going to pause the video until I get to 28 seconds in my voice. 24, 25, 26, 27, 28. There we go. So now it should be linked up better with sound. So a normal distribution, remember the bell curves. Here's my sad attempt at drawing the bell curve again and again. Alright. I find it very difficult to draw accurately on this. Good thing I'm not an artist. Maybe Kinsley, you can draw for me. So here's my next attempt at trying to get my bell curve to look pretty symmetrical. Remembering that we want it to be exactly symmetrical on both sides of the center. And being able to draw a straight line for a center would be helpful. And this does not have any tools like paint where I can just snap and draw a straight line. It all has to be done by hand. So continuing on, the center line, remember, is our mean, our median, and our mode for normal distribution. They all line up exactly in the middle, and that's how we know it's normally distributed. Remembering that mean is our traditional average. We add everything up and divide by the middle. Our median is the middle number when we put them in order, and the mode is the number that occurs the most. Normal distributions are going to be unimodal, meaning that there's not more than one mode. It's not bimodal. Up next, I'm going to show you skewed distributions. Remember when we talked, we had normal distributions, and I said we also have skewed distributions. We're going to have positively skewed distribution and negatively skewed distributions. If I knew how to edit the video, I would take out all of this writing because it takes forever to write it all out, and I talk a lot faster than I write, or I should have written and talked at the same time instead of trying to record. I think this is my 5th time going through the entire thing. Hopefully it'll record this time. It tends to like to record when I test it, but not when I go through the entire thing. And here's my inability to spell, guys. So when we last talked about distributions, we also discussed positively and negatively skewed distributions. Now, being able to draw the negative and positive skewed distributions is a little bit difficult as well for me. Even though they aren't symmetrical anymore, I was having a hard time making it look exaggerated. So when we're drawing them, if there's going to be a tail on one side or the other. If the tail is on the left side of the curve, it is going to be a negatively skewed distribution. Here's my, not a good one again. Maybe if I draw a line underneath, it'll work. Hey, look, a line. So there's the tail I was talking about, and then you have the bump there. Now, they'll never actually touch that line at the bottom, the x-axis. They're just going to extend close to it. This is our negatively skewed distribution, tail to the left. On our positively skewed distribution, our tail will be to the right. So we'll have a large curve, and then it goes down to the bottom almost. This is our positively skewed distribution. Now we have positively and negatively skewed distributions. Our mean is no longer in the center. Our mode is no longer in the center, and our median is no longer directly in the center like we had in the last one. So negatively skewed, we have our mean towards the left with our tail, medians in the middle, and modes to the right. The opposite is going to be true on our positively skewed data. We're going to have mode to the left and mean to the right because our tail again is towards the right and median is still going to be in the middle. So in our skewed data, our mean is going to be on the side near our tail. Our mode is going to be on the side without the tail, and our median is always going to be in the middle. Next up, we're going to have what the equation of this normal distribution curve is going to look like. We have y equals e to the negative parenthesis x minus mu squared divided by 2 sigma squared. And that's all going to be over sigma times the square root of 2 pi. Remembering that e stands for 2.718. It is a constant number. Pi, again, is a constant, 3.14. Mu is our population mean, and sigma is our population standard deviation. Remember that shape is going to depend on the two parameters of mean and standard deviation when we're looking at our curve, because those are the two data points we are putting into the equation. I'm going to try to find you some normal distributions that are not the same, and I forgot to pause it, and this is the fourth time I'm recording myself saying, oh, oops, I should have paused that video. Maybe Austin can show me how to clip video so that way I can make this go a little bit better next time. But here we go, we're looking for, I want them to have the same mean. Oh, I want them to have the same mean, but I want them to have different standard deviations. But I get lucky, I find a picture that's going to work for both examples coming up, and I only have to copy and paste once. Remember that the normal distribution is a continuous, symmetric, bell-shaped distribution. Filling up time. Do, 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 do. Can I figure out how to do this? Oh, can we get our pen? According to my computer, you're still recording my voice. Let's find out in another 2 minutes if it actually worked. So here we have two normal distributions. Normal distributions here have different standard deviations, but they have the same mean. Notice the center of both of the curves lies right on top of each other. That is our mean. Also a normal distribution, it's our mode and our median. But in the case of finding out the shape of our curves, we're using mean and standard deviation. Notice in the other one, they have the same height, they have the same standard deviation, but they have different means. The centers of both of them are not in the same place. There's two lumps there. And that's all. Maybe. No, there's more. There we go. So here we have the normal distribution, and you can see in the normal distribution, the whole thing adds up to 100%, or 1, if we're talking about probability. We have under the first standard deviation, which is the dark blue area. The area that is dark blue is 68% of the data. We talked about this earlier, so I understand if you already have it in your notes. Then we also have two standard deviations. That is the dark blue area and the orange area. Notice that that is two standard deviations away from the mean in either direction. That is 95% of our data, or the area underneath the curve. Lastly, we have three standard deviations, and three standard deviations here goes all the way out to the light blue section. That is 99.7% of the area underneath that curve. And that is all, folks.